Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In the previous video tutorial 189, we started our exploration on the neural network MLP classifier within Earth Engine, within QGIS. It sits there, neural network. Okay, so that's what we're going to look. That's number 4. So we've done Tetsaka, we've done the classifier, we've done the classification tool, and now we're busy with the neural network tool within QGIS. Okay, so that's the one that we're gonna work with, and it has a number of functions, options, its parameters, whatever you want to call it. But remember what we did in 189 is to make sure that the two files, our daytime image, our band stack, and our training image in the raster is exactly the same extent. If it does not have exactly the same extent, and when I say exactly, I'm not exaggerating, I mean exactly the same extent. Otherwise, it's going to give you errors. So have a look at 189, because if your two rasters are not the same extent, it's not going to work. Okay, so now we've done our raster, and it's our training raster or training image, and it's exactly the extent of our band stack, our Sentinel band stack raster. So now we can proceed. So we remember this is a plugin, so you just go to plugins, look for it, install it. It should be located within your processing toolbox. And there it sits. Okay, so our image will be our band stack raster. Remember, we've created it. That's got 12 bands, all 12 Sentinel bands, and we've created that using our semi-automatic classification plugin. So we've used it. We just click on that. You'll see there it is. There's our band stack. Okay, so that's our band stack. We've created it. Then our training image. Remember, it's got exactly the same extent, meaning width, length, coordinates, etc., etc. Remember, no data in all of our ones, our conversions, we said no data must be equal to 0. Now here comes some of the interesting stuff. Let me just close this as well. We're not going to work with this now. Now here is some of the parameters. Now, number of hidden neurons for each layer. Now this is trial and error. Again, it most probably will depend on your specific region of interest and your number of bands. The default is 10. I think you can keep it at 10. I know in my case we have 12 layers, so let's make it 12. Okay, you can do additional, there's some permutations what you can do here, etc., etc. But again, it's really up to you to go and test it. Okay, it's a abbreviation is there. Go and look at the website as well. 10, 12, 20, it does make a difference. It does make a difference. So let's go for 12 for now. Maximum number of iterations. Now here it seems to be that the more is better. Okay, the more is better. So I'm going to make it 2000 for now. So I'm going to make it 2000 now. Test size, I'm going to make it 20%, meaning 80% will be used for the image classification, 20%. Then I know already that logistic doesn't work. But anyway, let's quickly run it. Let's quickly run it and I'll show you. The rest I'm going to leave for now. I'm going to leave for now, and let's run it. And you'll see that when the classification is done, okay, it will give me a whole lot of errors. So the logistic is not working. So identity, let's run that and see what happens here. Also give me errors. And I don't know exactly why it's giving me errors. There's a problem somewhere. So let's make that 0. And let's run it. Okay, so that's what it doesn't want the test to run. Okay, so let's quickly just remove it. And these you just learn as time. So neural network classifier. So we're gonna go our band stack again. We're gonna go our training image. No data is 0. I'm gonna make this 12 because I've got 12 layers. I'm gonna make 2000. Test size, I'm gonna make a 0. I wonder if it's a point. If he doesn't want it point, I change it to a comma the whole time. So let's make it 0. You see logistic, let's run the logistic and let's just show you. It's going to classify, but you'll see it does not classify all 6 classes. It only classifies from classes 2 to 6, which is obviously not what we are looking for. Let's change that to 24, and see what that does. If it corrects it. Nope. So that's not working. So that's why I'm saying I'm generally not using the logistic function because in my case it is not working. So I'm going to remove that. Okay, so I'll rather use the identity function. Okay, so now obviously we have to give it a name. So output file, probability, I'll show you what that does now. Output file, we can give it output file, plot the file. That gives you a image, a PG, what's it, a PG image of it, picture of it. Here we have, it saves it into a raster classification. And I'm going to press on this, save to file. And then I'm going to give it a name again, image classification. So we're using our neural network. I'm going to just, I'll add the details now, neural network. And I'm going to say we're using identity and we're using 12 neurons and we're using 2000 iterations. So that I know what the parameters were that I use for this classification. Okay, so we're going to say run. Okay, there's actually, see, 6 to 1. 6 to 1. So let's quickly see what that looks like. So I'm going to go right click, properties, and we're going to go single, I'm going to go style. I'm going to load the style. Remember, we've already loaded the styles for the classes. So for consistency, we use the same. And we're going to load style, close, and okay. And there's our classification based on 12 neurons and 2000 iterations. Now let's change that to 24 neurons and let's change that to 5000. Leave exactly the same. I'm just going to make this now 24 and I'm going to make this 5000 just to see the impact of these changes. And we're going to run. Just want to so it's up there. We're going to run. And that is done. Let me just make this a little bit closer. And we're going to give it our style. So we're going to go load style. And we're going to select our style. And load. Cool. So there's a difference. So that is 24 neurons, 500 iterations. And that is 12 neurons, 2000 iterations. Now, the 12 neurons, 2000 iterations look much better than the 24 with 5000. If you just look at the mountains. But somewhere, you see, the 12 and the 2000 has got too much mountains. And the 24, 5000 has too little mountains. So somewhere between the two, we're going to get a midway between the two. Yeah, so play around with this. Then obviously we can also run the 10, and I'm going to leave it as is. Well, let's make it 20. Let's make it 20, and let's make that 3,500. So I'm going to go here, tang, TANH, and we're going to say this is 20 and 3,500, and let's run it. And there it is. So let's quickly add the style to it. So we're going to go style, add style. We're going to go and select our style. And we're going to say open, and we're going to load our style. Close, close, okay. And there it is. So that is identity 24,500. That's a tang 23,500. That looks sort of in the middle of the previous two. And you can do the rest the same as well. You can do now, let's say for ReLU. So let's keep the same parameters and just do ReLU. And let's run it. Let's see what that looks like. And we're going to load the style, properties, and we're going to load the style here. Select the style. Oops, sorry. First go and select it and select the style. Close. Okay. And okay. And there it is. That's a Talu. You see now that one has got a little bit more urban than the Tau. So you'll have to go and play around with these, change the parameters, etc., etc. The tan, let's misspecify a little bit of the urban areas, not much, but it doesn't over-specify it, where the ReLU seem to over-specify the urban areas and under-specify the mountains. So the tan 23,500 iterations seems to be fairly okay. Now, obviously, we can fine-tune it still. We can play around with the parameters, etc., etc. Remember to save it. Now, let's quickly do the following. Let's use which set the tan 23,000 seems to be the accurate one. So let's go the tan. Okay, so let me show you what we're going to do now. It's the tan. So we're going to use this. And when we're going to say, okay, select the probability of a class. Okay, so what we want to do is here is just remember we've got 6 classes. We want to say what is the probability of our selecting in this classification a particular class. So I want to go and see what is 5. Our class, remember 5 is our urban area. So I want it within this parameters, what is the probability of us selecting class 5? So I'm just going to go here, underscore here, and say it is class 5. So it's going to give me an image that is a probability image of the classification correctly classifying urban. Okay, so that's the beauty of this particular one. So let's go class 5 and let's run it. And you see it will give us an image that is not that we're not going to classify. It's not a classification image. It gives you 0 to 100%. So what I'm going to do is I'm going to use our Placido color, and I'm going to use our normal turbo, classify, and do this and classify. So the red is okay. So red is the probability of accurate, high probability of correctly identifying urban areas. And you can see this is that cloud issues that we spoke about. This is the town areas. So yeah, it's not very accurate, to be very honest. Let's just so let's go 4 is for agriculture. So let's just for contrast run run that and see what that looks like. So properties, we're going to go pseudo color, classify. Okay. Okay, you can see here where it works. These are correctly specified. All these reds are where it's correctly specifying agriculture. Remember, class 4 is agriculture. So class 5 for urban, it's not very accurate in predicting urban areas. In fact, it's terrible. Class 4, however, it is very accurate in predicting urban agricultural areas. And obviously, we now need to add them into our spreadsheet. And I'm going to do 4 again, I think. I'm going to have to do 4 of them. We've done, I think we're going to do 1 of each with the same parameters and maybe 1 with a slightly different parameter. So that will give us our 4 images that we're going to add into our spreadsheet to compare in terms of accuracy. But yeah, so we'll play around with that. We'll play around with that to see. So there is our neural network MLP classifier within the processing toolbox. Tool, double click on it. As I said, the important thing is to make sure your image and your training image are the same in terms of its extent. If it does not have the same extent, it's not going to work. Then I said, in our cases, we made our no values -1. Let's, if it was still -1, let's see. And let's keep identity, because we know identity works. We know that logic works. Let's run it now and see. It's most probably also going to give us an error. Let's have a look and see. If it takes so long, it's most probably going to give us an error. Yep. Because we've misspecified our parameter as no data value. We've misspecified it. So again, when we do this, the no data, please make sure that wherever you have the choice, make it a 0. So that's another point. Okay. Okay. No, well, in fact, it has done it, which is interesting. Let's see what that looks like. Classify properties. My apologies. I thought it's going to give me a. It's going to give me a 0, an error. So let's go class 1, open it, load the style, close. But you can see it looks terrible. Anyway, so yeah, these parameters you will have to play around with. Play around with these parameters to see which ones work, which ones don't work, which one seems more plausible, less plausible, etc., etc. So as I said, in my case, logistic doesn't work. So we've got the 3 methods here, and each method you can change the number of neurons and the maximum number of iterations, and these 2 values are really up to you. You can play around with them to see whether changing this, changing that works or not works, whatever the case might be. So that's a neural network classifier, boys and girls. So I said it follows up from 189. So yeah, it's worthwhile. It's another tool in our toolbox. It's another neat little method within QGIS to do land use, land cover, image classifications. And as I said, its nice part is this probability of predicting a specific class. I like this. This is quite unique to this specific classifier. It is a confidence maps, but it's confidence map for a specific class, which I think is quite neat. Okay, so yeah, let's park it for there. That's our neural network classifier. That means now we have 4 done. 4 classifiers, 4 tools, classification tools done. Remember, we had Zitsaka we started with. Then we had the supervised classifier. Then we had the classification tool. And now we've done the neural network classifier. So that's 4 done. We're now going to go to OTB, We're going to do the classification in OTB. That's number 5. Then we're going to do the classification in our semi-automatic classification doc. That's number 6. And then once we've done, remember this is still pixel classifiers, which work on the spatial resolution, of the spatial spectrum. And then we're going to do object-based, and we're going to look at how we're going to do that as well. So that will be then another one that we're going to add to it. Okay, so with that said, that's neural network classifier. Neat, nice, and definitely something to take into account when you do your classification. So with that said, cool, yeah. I think there's nothing else that I want to add. So with that said, I'll see you on the other side.